Alright, first, let's see exactly what this problem is asking. This jet plane is saying is going at a takeoff speed of 66 meters per second, and it has an average acceleration of 1.7 meters per second squared, and the length of the runway is 2.4 kilometers. That's interesting. This is asking if the plane will use the runway safely, so that tells me we need to solve for x. We are also not given time. To sketch this out graphically, we see here that it's going at an average acceleration, and then that top mark is 66 meters per second, and we are solving for the whole area under the curve. So let's just denote that with a different color. We are solving for everything here, and we are trying to determine if this is less than or equal to 2.4 kilometers.
So let's write out our givens. We know that our initial velocity, VO, equals 0 meters per second. And we also know that our final velocity, just V, is equal to 66 meters per second. Our average acceleration is 1.7 meters per second squared, and the length of our runway is 2.4 kilometers, which can be converted to meters by multiplying by a factor of 1,000, giving us 2,400 meters. Now let's plug all of our information into our kinematic equation.
Which kinematic equation would that be?
V squared equals VO squared plus 2A times displacement, which is x. Delta x.
So we can rearrange this equation to solve for x. We know VO is 0, so we can just x that out. We know V is 66 meters per second because that is the takeoff speed. That's the speed it's going to be leaving at. And we know acceleration is 1.7. And that is equal to x. Delta x, my bad. So then, converting this, we know 4,356 meters per second squared is equal to 3.4 meters per second squared. The second squared cancel out. This has sig figs aren't too important here, and then we can make it equal to 1281 meters. We know 1281 meters is a value that is less than 2,400. Therefore, we can safely assume that it will travel the runway safely.